Okay, let's try an example. So it says, a 15-foot tree casts a shadow of 5 feet. Assuming that the height of a tree is proportional to its shadow, how long of a shadow would a 35-foot tree cast? All right, so what does the variable represent? Well, we're not quite sure. Like, it doesn't tell us as obviously as the last problem. So let's go to the question that the problem is asking, and that will help us. It says, how long of a shadow would a 35-foot tree cast? So we could say that x would represent, well, the length of the shadow, right? We want to know the length of the shadow of the 35-foot tree. Oopsie. Okay, step 2, it says, find the two quantities in the problem. Now, quantities kind of represents the two topics that it's talking about in the problem. So we can see the problem has this trend. It's saying the height of a tree, right? And then what else is it talking about? It's talking about the tree's shadow. So we can say quantity 1 represents height of tree. We can say quantity 2 represents the shadow of the tree. All right, so now we're going to set up a proportion since it said that the height is proportional to its shadow. So quantity 1 was the height of the tree. Now, we know that the 15-foot tree, we're going to put that up here, over quantity 2, I'm getting that from right here. Well, quantity 2 is a shadow, and it tells us that the shadow is 5 feet. So 5 goes here. Okay? Now, we want to move back up. Quantity 1 is the height of the tree. So we know that the height of the other tree is 35 feet, so that goes here. And we don't know the shadow, right? But we want to know the length of the shadow. That's our x. And now that we have set up our equation, we can solve. So step 3 says solve for x by using cross multiplication. So we're going to cross multiply, and we get 15x equals 175. Now how do we get the x by itself? We want to divide by 15, right? Divide both sides. They cancel over here, and I'm left with x equals 11.67 feet. So that would be the shadow that the 35-foot tree would cast.